some of the great partnerships that we have and initiatives, and maybe some topics that you're not familiar with, such as LLMs and humanoid robotics, essentially giving speech-to-speech reasoning and intelligence and cognition to robots that we see more commonly with Tesla and Figure, but we're moving obviously into the UAV, AUV, and ROV space. So I actually can see the chat, and I think I'm just gonna handle some of the questions on the fly. I may stop at a few points and then kind of use this as more of a conversational presentation and an hour rather than throwing everything towards the end. So if you do have something, feel free to ask it, and I will stop for you. And I'm sure the next 53 minutes are going to go by super, super fast. So, just quick about me. I am doing exactly what I love. I am in startups. I'm in marine tech. Through my position of being in corporate development and M&A and strategy and sales, I get to do, this is the Japanese concept ikigai, which is a concept for purpose and a reason for living. And so I get to do something I think I'm decently good at, maybe the world needs, definitely getting paid for it, and I love it. So I'm having a blast being able to manage partnerships, product roadmap for VideoRay, and build new technology. And I'm in St. Petersburg, Florida, at a place called The Hub. Saildrone is there, and a few other marine technology companies. St. Pete's fast becoming a marine robotics and marine technology epicenter. And you have SOCOM and CENTCOM and special forces here. And so there's quite a bit of money for research and development and top tier technology companies. And St. Pete's just a great place to live. I started my journey and my entrepreneurial path in ocean technology, building camera systems. So I was on the forefront more than 10 years ago, starting in Hollywood, building Hollywood-like cameras that were some of the highest resolution, first of its kind, doing this and that, and worked with MSG Sphere, SeaWorld Abu Dhabi, who else? A number of different companies that you've heard of: Google, Meta, Apple, and through that, it was interesting. But I think my heart's definitely more in defense tech and applied research, and taking a lot of these concepts in big cameras and putting them into small form factors and making them more scalable and prosumer friendly. As these cameras were very technical and expensive and hundreds of thousands of dollars, I'm trying to build solutions that are accessible to everyone, less than $10,000 or $20,000. And so I built a lot of prototypes. I came from a background of really exploring mixed reality and multi-view imaging, 3D stereoscopy, volumetric imaging, and was able to really have other people pay for my work, which was and through that I had a company called Blue Ring Imaging, which I'll quickly touch on. But while I was at Blue Ring Imaging, we created the first underwater 360 3D camera system, developed essentially 360 camera systems for submarines, and also did live broadcasting in 360 and virtual reality, and no one had done that up to that point. And then through that, I tried to marry these immersive camera systems with mixed reality, which I was really passionate about, trying to put everything together, and partnered with Embari. We took a look at the piloting problem. The way that FPV solves situational awareness in the aerial space. How can we accentuate and amplify operator performance, around manipulation, navigation, transiting, and essentially, turning new operators into experienced operators as quickly as possible. There were a few white papers written. The first one was in 2018. And through that, Blue Ring Imaging was acquired by VideoRay about 10 months ago, and they brought that technology and those concepts into their portfolio, and we're developing them now internally. So VideoRay is growing quickly. We're a defense tech company. We have doubled in size over the last year. We have been around 25 years. We started in very small ROVs. We've kind of worked up the food chain, and now we are, in the inspection class space. And let's see, I mean, working across every segment. Oil and gas, aquaculture, defense, science and research, exploration, shipping. I mean, you name it. There is a customer. If they're working underwater, we're talking with them and have relationships with them. And we're very blessed, having been around for 25 years, to have long-term relationships with many of them. But we're primarily a defense tech company, and a large portion of our business has come through working with the EOD and mine countermeasure groups, and that has proliferated into a program of record. Program of records they're rare, they're scarce, they're not easily attainable. They don't come that often, and there's only a few of them with lionfish that HI has, and knifefish as well. Then you also have tetra and oceaneering, and then you have Messer. And there really isn't a lot of other examples in subsurface robotics right now in the Navy with program of record contract vehicles, which really allows for scalability in and around the Navy, and expanding markets and being able to bring other groups to more quickly and accessibly adopt underwater robotic capabilities. So we're very lucky there, and we focus a lot, and through this relationship, we're pushing the limits of autonomy, manipulation, depth, mine neutralization, and if you guys are familiar, there's two adages, detect to engage and find, fix, and finish. And so we're very much a part of how to identify mines and neutralize them through a human on the loop, and no divers in the water, and then also the same thing, finding, fixing, and finishing at all depths. So we have 5 offices, and I'm in St. Pete holding down the office here. We have one in a robotics lab in Pittsburgh, a support office in San Diego, and then our headquarters is in Pottstown, Pennsylvania. We have 3 vehicles that we are primarily supporting. We have, most of you may know, the Pro 5, but for the most part, our customers today are buying these 3 kits: the Ally, the Deep Defender, and a 300-meter Defender. And there isn't a lot that's been shared around the 1-kilometer Defender. I was just going to quickly brush, do some brush strokes on that today. But something you should know about us is we are known for our modularity, our ability to swap thrusters and comms modules and tethers and compute between each of the vehicles, which makes them more easily supportable, and you don't have to ship the vehicles back if one thing breaks. So it gives them a whole lot more support and ease of use in the field. And this is why a lot of our customers go with us, is around the reliability, ruggedization aspect, that someone not with a whole lot of technical knowledge and competence can handle doing very complex tasks. And so that modularity plays itself out in that we tend to try to use a lot of the same components to build and rebuild for different applications. And then we certainly do that now at a stratification of different depths. And so with the Ally and Defender at 300 meters, many of those parts are the same. We love to sell those as a couple. We love to sell those in kits. and they each have their own special place in the mission sets for each of our commercial and defense clients. I think I saw Marcus hop on, and I wanted Marcus, our Chief Product Officer and brainchild of the Deep Defender, to do a quick 5 to 10 minute introduction of the Defender. And I guess, Marcus, are you able to go off mute? And are you able to do the introduction? And if you're not, that's totally fine. But if you are, would love for you to hop in. And I will keep going. But Marcus, if you can go off mute, would love for you to weigh in a bit, and we can obviously revert back. So with that, the Deep Defender system has different components, obviously, than a 300-meter system. The comms module, the camera, many things don't work at deeper depths, and they have to move from aluminum to titanium. And not all the sensor manufacturers are prepared to work at those depths. And so there is a lot of extra work and considerations in how you put together a deep water vehicle. And obviously ROVs can't necessarily, with being battery powered and all of the long tether that goes, that's required to go to a kilometer or deeper, that is a constraint. But the reality is that we're moving into these fly out situations, and we're moving into more teaming opportunities where AUVs and work class ROVs and submersibles have needs for smaller vehicles, serving almost as a mothership. And the Defender, maybe not able to get down to a 3 or 4 kilometer depth on its own, can certainly do work there that's very valuable for customers. And so that is a longer conversation of, how do you get to those depths and what is required. But once you're there, the Deep Defender is well situated in a great spot for being able to handle that. So as you're reading these slides, you can see that the kit has everything that's deep ocean rated, and anything from the batteries, which needed to get changed, to the sonar, the camera, the power modules. It's just, it looks and feels like the Defender, but it has obviously more deeper rated components. And we use the same splash proof controller that we have on the 300-meter vehicle, but we've moved to a 1,000-meter Oculus sonar. We've moved to a different Nortec DVL that has a deeper depth and titanium housing. We have different blueprint transponders that are able to handle these depths, and then we've made new batteries, and these batteries can handle, obviously, with a 2 to 4 hour runtime. You don't want to use that going all the way down to the ocean depth and then having to make its way back. So that's another conversation for another time that Marcus could certainly weigh in on. And there is a sales engineering and technical conversation, but everything's deep ocean rated, and what that allows us to do are flyouts. And this is what we're being asked to do by our customers and partners. And this is the new forefront for work class ROVs, or for inspection class ROVs, and for these man portable systems. There is a need for eyeballs, which is essentially triangulating manipulation, having situational awareness, doing intervention in smaller confined areas. And work class ROVs are large, they're bulky, and they have a need for, in many cases, for something like a Deep Defender to do the work once it gets down there. And there also are a lot of requests around object reacquisition. AUVs, when they get stuck in a fishnet, or if their battery runs out, they don't necessarily hit the surface. Something needs to go and reacquire them. and ROVs are obviously a good fit for that. And then you just have, you know, more autonomous inspections and human on the loop types of interventions that, you know, unmanned vehicles are transporting other unmanned vehicles to go do work. And so through that, we're working vigorously on relationships, launch and recovery partnerships, and you know, different types of vendor solutions with some of the best and brightest in the industry, you know, on specific projects, so that we can have ROV to USV teaming, work class ROV to defender teaming, and like I said, you know, AUV and submersibles and others. And DEPRO is a relationship that we have been, you know, very vocal about and very outspoken about. We love this this partner, and they were showing their kit and with us at Oceanology, for those of you who are there, and we're certainly selling more of these as to make a more automated launch and recovery process for our customers, and from, you know, some of the work class ROV companies. And so with that, I'm happy to take any questions, as I'll be moving to cameras and imaging and more of the things that, you know, I focus on from a day-to-day basis. But from, you know, is there anything about the company that you would like to ask before I make a big transition step and have my have a quick swig of water? All right, so I'm still following the chat, and I'm happy to stop and answer any questions. And do you know any hardware? Do you do any hardware at home office in Pottstown? Yes, we do all of our manufacturing, Leslie, in Pottstown. So any of the vehicles that you see are developed in America, in the US, at our facility in Pennsylvania. So we have third-party sensor integrators, and I just want to touch on these briefly. These are relationships that we're very proud about, and provide extended capabilities and value to our customers in areas that, you know, are not necessarily our specialty. So in the sensor domain, we have Varst, IVM, and Voyus, and each of these three companies have very cutting-edge solutions around 3D reconstruction, 3D modeling, photogrammetry, and inspections. And you guys can certainly do the homework, and we're happy to help advise, but we love each of these partners for who they are and for what they're doing and the value that they offer. And they and we have, you know, tight integrations that we are very proud about. And then we also have Reach robotics manipulators that allow more high fidelity manipulation underwater. And for those of you who have maybe seen videos online, the Navy and a lot of the defense clients that we have, you know, if we're going to do mine neutralization and take a commercial diver or an EOD diver out of the loop, then they have to do the same types of things that an ROV has to do the same types of things that a human does, right? And so, you know, for example, you may or may not have seen this recently. This was posted, I think, last week, but an expeditionary ROV in current with a new inexperienced operator could untie a bag and could pick something out in just a few minutes. And that level of accuracy and that level of performance is something that, you know, more and more customers are asking for and getting excited about in the performance envelope. We have kinetic effectors to do what we call essentially low ordnance or high ordnance bomb disposal. That it's a little bit like a shotgun that you know, is able to handle mine neutralization from a distance, or you know, do some of the dirty work that you don't want a human in the area. And then we have 3D sonars such as Coda Octopus, which you may have seen at the Baltimore Bridge. A lot of the Coda Octopus sensor data was shared on CNN and ABC It's a best-in-class 3D sonar that we have a very tight integration with. And then LiDAR. So there are cutting-edge LiDAR companies, some of which are not really publicly known at the moment, that we're working on integrations with to augment, visual information and data collection. And LiDAR has about 4 to 5 times the range of a camera in turbidity, but it's producing a real-time colorized point cloud that is useful for visualization and can be seen in real time. So LiDAR is obviously, as you, a LiDAR does not produce a colorized point cloud, but it does produce a point cloud. But when you fuse it with a camera, you do get the colorized point cloud. But this is something that you would see on, on a lot of Waymo vehicles, a lot of autonomous cars. They, other than Tesla, which is camera-based, most, if not all of them, have a LiDAR in order to see and understand the world. And then L-Wave. L-Wave is one of our latest and greatest integrations, where it can see through sediment and identify buried objects. And it's what's called biomimetics. That was a new term for me until recently. But without needing to uncover uncover dirt, or being able to dig, and obviously there are different reasons why you would want to see something like a cable or a pipe under the sediment without having to deal with that environment. L-Wave is a great partner for doing that, and they're new, and they're a French company, and currently translating a lot of that into English, and we can certainly provide more information if you are interested. So we are at about the 30 minutes, and I'm going to talk about cameras, mixed reality, and LLMs, and which is essentially robotic intelligence, and cover the wave tops there. So our 4K video, our 4K video smart camera, which is an NX. This was something that I was developing while at Blu-ray, and VideoRay has adopted it, and it's now going out with all of our current vehicles and shipping with the Ally and future Defenders. And what's unique about this is it's a fisheye lens. So it's electronic pan, tilt, and zoom versus mechanical pan, tilt, and zoom, which is not widely common in the industry at this point. And there is a difference. And so for those of you who are may or may not be familiar between what they would call ePTZ versus just traditional PTZ, with a normal mechanical PTZ, you have a narrower field of view, you have parts that wear, you have blind spots, you do have a greater magnification range, but there's a lot of downside that we feel that ePTZ is better suited for the customer. And it has a wider field of view. It's easier for target tracking and following. It's got better situational awareness, and it's more intuitive for the operator. And so essentially through a what we'll call simulated software, you can move the picture around within this large field of view in order to see the image. And so through that, we have not yet released a lot of imagery, but here are 3 examples. At depth in turbid water off of the Pacific coast, where you can see the image is great. It's a IMX 400 series sensor, and we're looking at integrating higher series in the future. But through this fisheye lens, you get a lot of value in the day-to-day operations, and you can even plug it into an immersive media player like YouTube, for example, and you can see that when I move this around, this isn't something that we've integrated into our system yet, but you can see how wide it is from edge to edge. And I think you're getting maybe 5 frames a second on the screen, but I can certainly share this. But it's a very, very, very wide fisheye, that's 190 degrees up and 190 degrees down. And this is actually not the camera. This is another fisheye lens that I created and filmed, but this is publicly available on YouTube and gives an example of what a fisheye lens could look like in immersive media format. And so we'll move on to the next slide. So, using this system architecture, we're now expanding on multi-view cameras. And multi-view is obviously my specialty. It's something that I've been involved in for quite some time. And, multi-view is something that, offers more situational awareness. It enhances data acquisition, being able to have more sensors on the camera. It allows you to see on all sides of the vehicle. But at the same time, there's a trade-off of complexity. There's a trade-off of more parts. There's never been an issue with multi-view cameras around what we'll call product market fit, but there has been an issue for quite some time around product market pricing fit, as the cost threshold has been often too much for people and not ready to be scaled from a manufacturing sense, because there isn't enough demand. And when you're talking about multi-view cameras on an ROV in a marine environment, it's very, very niche. And so we've been ramping this up slowly, essentially doing this made to order with our customers, and really focusing on the use case and focusing on what specifically they're trying to achieve, and working with a lot of similar components, which is NVIDIA AGXs, NVIDIA Orins, and then through that we have different applications. But we tend to distill this down into 3 options with our customers, and I'm working with AUV companies, I'm working with deep submersible companies, I'm working with USV companies. I mean, multi-view is something which is super common. You see on, a Skydio UAV has over 6 cameras. A Tesla car has over 10 cameras. Shield AI drones. Everything's moving towards having a better understanding of the environment, and ROVs are kind of last to that. And so we're actually working with other ROV companies, especially in the work class space. And in the future, VideoRay will make this more common and standardized. But right now, it's a bespoke solution that a customer has to come to me with a specific need, and then we build it for them and support that. But we essentially have from anywhere like a low baseline entry market solution, and then a very full-fledged solution, which is high performant. And there's very different price points, but the situational awareness one is an NX. It's 4 sensors. Each sensor shoots out 2K resolution, and then there's a common interface, which I'll share with you. And then there's one which is an AGX. It offers more ATR and stitching and added compute, which allows to do other things concurrently than just video streaming, and whereas an NX necessarily wouldn't. And then the sensor fusion 360 system can be one or multiple AGXs, one or multiple NXs, depending on the use case and the size of the vehicle. And we'll sometimes fuse IR, we'll fuse different types of lenses and sensors into a common operating picture, that brings all of this standardized video data into one common place, and then sends that to the customer, which is very useful when you're having to deal with remote operations, or you don't have a tether and you need to be able to provide a singular low data rate video stream from 5 or 10 or 15 cameras, where you couldn't be able to send those 15 streams all at once. So that's where the sensor fusion comes in handy, is that you're trying to get a lot of sensor information fused into a single stream for the operator and the team to make decisions. So there's a number of different configurations that we've been exploring and releasing to customers. And some of these have have actually been sold and some have not. We've just been testing them in-house. But you can even use our VideoRay 4K smart camera, sync a few of those together on our VideoRay Defender today, and you would have a multi-view camera interface. And there's a couple different interfaces, or what we'll call HMIs, human machine interfaces, that we're able to present this multi-camera information to the customer. The most rudimentary is simply just putting all 4 cameras onto a screen if the number is 4. And then we could move to a stitched solution. This is unwarped, right? So this is on a USV. So you can see the full 360 on a flat screen. And you can see that there's ATR, which is overlaid, identifying some of the ships and objects in the scene. And this is actually pre-recorded footage. We have not released this to any customers doing this in real time. It is possible. There's just, we would need, for example, an ATR algorithm if the customer needed to identify something on the horizon. But this is more of a conceptual video, which I'm providing to just give you a sense of, what HMIs can look like using a multi-camera video. And then you can do something like I shared with the first YouTube video, but this is online. But you can see all around. So this was a 360 camera on a submarine, and being able to see either pre-recorded or in real time, being able to see all around, either depending on the configuration of the cameras, it could be a very tight orb like what you see here, or it could be around the sub itself, where the sub, you don't see the sub, you just see everything around the sub. And so through this, I'm getting, obviously on my screen, 60 frames per second. You guys are probably getting something around the order of 5 frames per second. You can obviously see why this would be valuable, especially if you want to collaborate and if you want multiple people inside an environment looking around, that they could each have their own video, that they could be looking in different directions. And so this is, hopefully this makes sense what I'm saying in terms of the number of different ways that multi-view cameras can be presented. And let's see, I know I get hung up on that. And then, and so when you marry this with mixed reality, you get something extraordinarily special. And multi-view cameras really shine, and you really get more of a sense of presence, and you take more advantage of the data when you're not looking at all of this information on the flat screen, but you're looking at it in an immersive environment. And this is what I've been exploring for quite some time, and I'll give you some examples. So wait one second, I need to take another swig. And this is really part of the future of work too. I mean, the future of work, and you see this displayed in Apple Vision commercials and Meta commercials about the Quest 3 and other companies. But the future of work is not tied to physical spaces and physical screens. Collaboration is easier. It's easier to interact with 3D information and objects. There's less overhead. There's less CapEx, obviously, because you just have one physical headset and a bunch of synthetic screens. And everything's more mobile. You're not tied to a physical place. And so everything's moving this way. I think you'll see in the next 3 to 5 years the Meta Ray-Ban glasses, that there will be more consumer-friendly, price-conscious, immersive hardware at that form factor that will be able to do something at this resolution and mobility. And so I'm kind of playing to the puck. Is I had a headset on 10 years ago, knew we'd get there, but hopefully I see it before I die. But I knew it was going to take quite some time, and compute is obviously a big consideration here. Let me see if I can now hide this. There we go. All right. So OctoView is something which we've created, and I'm going to show you a number of different interfaces for that, which you can stream traditional 2D data or immersive camera data in order to provide an enhanced experience for the operator. We've done a bunch of academic research at this point. It's proven, really the biggest constraint is hardware. Hardware is not necessarily ruggedized at this point. It's not great in sunlight, and Meta Open doesn't give you the ability to easily interact with the app that you build. You have to navigate into their app store and library and other content, and not everyone's ready for that language. The human machine, the HMI language of learning how to use a mouse versus learning how to use a keyboard, versus there is a language for immersive media. There's a language for HMDs, which the mass market has not learned yet, and it will take a few more years. But once that becomes ubiquitous and commonplace, there's going to be less training on the front end and more content and applications that you can distribute for less cost in the future. But right now, no one has headsets, and there has to be training, and there's a lot of support. And it's not an easy technology to do successfully without really expert oversight. And so through that, I've had to be pretty selective in who I choose to use this. But when we have partnered with someone, it's been extremely successful. And Oceaneering is one that I'm allowed to talk about, and they're going to be actually doing a presentation on it at Underwater Intervention and Workboat in November. But we've been testing this on many different types of vehicles, from OceanX to Mbari and the Navy EOD. And we've had just a ton of really great responses, and certainly learned the environments that work best for headsets. But at the end of the day, when someone has the choice between using a headset or using a phone or 2D controller for being able to see the screens, they very often choose the headset, and they prefer that. It's just not available to everybody at this time. And so, two anecdotes, and is one from Ben Irwin, who was an ROV pilot. He has many high remarks to say, saying that it was mind-blowing, and that things that were hard before are now easy. And then Greg Diffendale with Ocean Exploration Trust was a pilot for I think over 5 years, who was very skeptical of the technology and didn't want to use it. But when he actually gave it a try, he was a full convert, and that's what we've seen in when we've given people exposure to the technology. So it's a very hard problem to move from vehicle through cameras and stitching, eliminating latency in a headset, and being able to give someone enhanced teleoperational control in a lightweight form factor. And that's what we've been working on. And so we've actually had to develop our own, what I'll call, game engine. Right now, it's just a series of tools outside of Unreal and Unity, because we don't get the low-level access to and knobs that we really need to turn around video compression that enable this to happen. So we tried with Unreal and Unity for a number of years and realized that for this to be successful, we had to do it on our own. And so I got a question: is there a reason you're using the Oculus instead of a Vive? We're agnostic, but I tend to like the Quest 3 for its cost and availability, and I think Vive gives somewhat of a half-hearted effort on the technology, compared to Oculus, which is spending $5 to $10 billion a year, in expanding the capabilities and making this price conscious for and affordable to the user. So, I mean, we could put this on a Vision Pro, we could put this on an Oculus, we could put this on a Vive. But if I had a preference, I would just go with the Quest 3. As we don't really like working with Steam VR at all. we would prefer to have a completely mobile setup. And Vive doesn't have a great end user backend or developer environment. And so when you marry Octocam with OctoView with an ROV, like I said, you get something extraordinarily special and will be, I think, quite common in 5 years among pilots and operators and teams. And we're right at the very cusp of that. We're already seeing it in Ukraine and in tanks. So there's a company in Eastern Europe that's now providing a hardware software solution for tank operators, and they put cameras on the outside of tanks, and now you can see this de-warped image, and they're protected inside of the tank, but they can see everything around them at near zero latency. And so the lower the latency, the more you can do. That's another conversation in itself. But the sweet spot is really around 100 milliseconds or less. And when you start getting to more, you got to work with very slow moving vehicles, maybe like an ROV. But once you get above 200 milliseconds, it's pretty much unusable. But within that range, you can fly. You can drive tanks. You can fly F-35s. I think an F-35 is near zero latency. It may be 3 or 4 milliseconds because they use FPGAs. But you can certainly see in more of the high-end manned and unmanned vehicles that this is becoming commonplace. And so, for example, using this is one of the interfaces for manipulation, but you can see that using a mixed reality headset, I would prefer to use mixed reality over virtual reality. You're getting a fisheye lens, you're getting this screen. It's a 3D screen, so you actually have depth to it, and you can move it around and take it anywhere, and be able to be both a pilot or a backseat driver or operator. And nausea is not a concern whatsoever, because you can, based on movement of the vehicle, expand or decrease the size of that. There's a number of tools you can do to mitigate nausea, and that is a research conversation all in itself. This is something that we've done for the Office of Naval Research and JTACs, who are starting to control more unmanned vehicles. But this is essentially a Quest 3 that is using, we're going to be moving actually over to more militarized HMDs in the future. But you can see a heads-up display that has low latency video feeds that can be, depending on the number of videos and the field of view of those videos, we can expand and manipulate those videos where it can either be primary or secondary to the operator, so that they can look around and still have full situational awareness, or hunker down and control an ROV. And so this is what's going to become a program of record in JTACs and getting talked about in the tactical handoff system, POR. But there are other HMIs that we've concepted, and we're currently testing with some of our customers. And you can see this is one that in virtual reality, but it could also be mixed reality, that you can stand in. So it's essentially a synthetic mission control room that is fixed to an environment, and you can leave the room or you can come back as long as you have the headset on. It's there. You stand in that circle, and then you have within that space synthetic screens that you can manipulate and move around. That includes sonar, map, and camera. And you can move this synthetic mission control room or virtual control room wherever you would like to have it. But we have different customers trying this out in their current physical remote operation centers. So that's one I'm very excited about. And then this is essentially a first-person field of recording where someone's in the headset and they're manipulating with their eyes. So there is eye tracking that can be enabled. There is voice, there is gesture. So, I mean, everything is synthetic, and they're manipulating all these screens and controlling the experience without, you know, any physical controls. And you can see that this is a 360 HMI that essentially had 3 screens around them. And then we've moved now to something that's, you know, full visual data of everything coming off the ROV. And this is more of a traditional conventional view, but, you know, depending on what the customer, on what the operator needs. Wow, I don't know if you can hear that thunder in the background. We've got a nice afternoon rain shower here. But depending on what the customer needs, you can overlay augmented reality targets. And if you have an immersive camera system, you can fix those camera positions that, you know, that you through just a head tilt, you can look around and have a better understanding of, you know, where you are in an environment. And we have a simulator that we show customers and show potential partners, you know, with different environments, both terrestrial, aerial, and subsurface. You know, how this works is there's a lot of universal concepts here, and once they, you know, put it on, they get it. So these are videos which I've posted online and shared, and it's possible to do, you know, remote operations as well. So not just tethered, but you know, through Starlink, being able to connect an untethered vehicle, as long as you have enough data rates, which is really about 60 megabits or more per second. If you can get that, then you can have a tetherless experience anywhere in the world. There are some latency considerations, but I'm definitely, that's a facile explanation at best. But long story short is, you can have a tetherless headset connected to a tetherless vehicle where that person, that vehicle, are anywhere in the world. So, you know, through the, let's see, this should be playing. We'll see. And I didn't think about the frames per second issue that you guys, the issue you guys were having. But essentially, this is a video which I could share later that explains these concepts from an aerial perspective and how they're getting implemented with ONR for drone control. Oh, here we go. Because these are things that not just ROV operators want, but everyone wants. So I think because of the frame rate issue, this will be hard to capture, but essentially there is voice commands from a JTAC, and he has his HUD, and he's interacting with a drone through voice, and he doesn't have to look down or touch anything physical in order to control one or multiple vehicles. He gets ATR into the HUD, and he understands what's happening, and then through that he can, you know, based on the commands that he needs to give the vehicle, he can either choose to do that through voice or gesture if, for example, it's a sensitive, an audibly sensitive environment, and he needs to keep a low profile. But this is something which we're, you know, definitely working on and incubating on more than work class ROVs. So lastly, with the little time we have left, this is a concept which is very new to a lot of people, and so I'm going to just touch on this briefly. But you know, we're moving from individual robot control to multi-robot control of coordinated tasks, to robots intelligently, you know, being interoperable and being able to handle independent collective tasks and have the intelligence on board to essentially do perception, cognition, and action. And LLMs, large language models, are a significant puzzle piece to that intelligence problem set. And so you'll see, in essentially what they call the humanoid robotics space, that they're trying to work on, actions, reasoning, cooperation, but based on different environments. Some of this stuff's already possible, and some of this stuff's in the future. But we're working on, how do you handle large language models and robotic intelligence in isolated environments, all the way to contested environments. And this is something that I can spend the rest of my life on, and we'll just be scratching the surface on. But we're exploring essentially with large language models, diagnostic aspects that we can give our customers, diagnostic capabilities where the vehicle with speech-to-speech reasoning can talk back to the person, or intelligently identify problems, pre-mission planning, and post-mission analysis. So I think with that, obviously, like I've shared with you, my email is casey.sapp@videoray.com. And I am happy to do a deeper dive with anyone who'd like to reach out. And with the little time I have left, I'll just knock out some of the questions. But I'm really thankful for everyone who came. A lot of familiar faces, and hope to keep the conversation going. So, general question about your ROVs: do you offer universities the chance to explore their own hardware mods by offering open source code snippets? Yes, we do. And that's a conversation we have on a weekly basis with different partners, both on the science and research domains. So that is something we care very much about, having an architecture which anyone can access low-level controls down to the thrusters. Anyone else? Well, I very much appreciate it. And it's been a really good time getting to see everybody involved. And thank you for spending an hour with me. And look forward to having more conversations in the future.
Casey, thank you very much. Really appreciate it. If you want to drop your email in the chat, so that way folks can reach out to you if they do have any follow-on questions, that'd be great. Once the recording is sort of processed and everything, I'll share it out to you, Casey, and then you can have your marketing team carve it up and distribute it however you'd like, and then we can promote it as needed through LinkedIn or any other channel. No further questions, everybody. I appreciate your time. And again, if you're interested in these type of events in the future, or actually having your company's technology showcased in a similar manner, please do reach out to me. I'll drop my email in there again. Thank you.
Thanks, everybody. Hope you have a great day.